This resource is the fourth in a four-part series on factoring polynomials. Part 1 considers the greatest common factor. The GCF is defined. We present a method for factoring the GCF out of a polynomial, and provide examples. Part 2 considers factoring a trinomial into a product of two binomials, where the coefficient of the x squared term is 1. We present the general process and look at multiple examples. Part 3 considers certain special cases. Those cases are defined, then examples are provided. Part 4 looks at factoring a trinomial into a product of two binomials, where the coefficient of the x squared term is not 1. We look at the general process, then multiple examples. Factoring quadratic trinomials where the leading coefficient, the a, is not 1 is more complicated than cases where a does equal 1. Now, not only do we need to be careful that our signs are correct, we also have to ensure that the factors are placed in the correct positions. There is no straightforward method for factoring such polynomials, so we are forced to work by guess and check. Sort of. We will be methodical to our guess and check approach. First, we will set up our parentheses, just as we did in the more simple cases. A minus at the end still signifies a plus and a minus inside our parentheses. Next, we factor the leading term. We then factor the last term, but we have to include all options. This means that if you write the factors in one order, you must also include the opposite order. Then we do the O and I steps of the FOIL method, the outsides and insides, to try to match to the middle term. Doing so, we will have three options. If our result matches the B exactly, then we are done, and we can write our final answer. If the number is correct, but the sign of the number is wrong, then we switch the signs inside our parentheses. If the number is completely wrong, then we can cross off that pair of factors and try something else. Some examples should illuminate. For example, suppose we want to factor 2x squared plus 3x minus 35. We start by looking at the last operation in the polynomial. Because we see a minus 35, we know that our parentheses will have a plus and a minus in them. Now we want to factor the leading term of 2x squared, which would be 2x and x. We place these factors in the parentheses. Next, we want to factor the 35. We can get 35 either by multiplying 7 and 5 or 35 and 1. When writing our options, we make sure to write both orders and have each factor in each set of parentheses. Now we begin trying to match to the plus 3x. We multiply the outsides and insides for the first factor pairs. We have 2x times negative 7 and x times 5. Doing the multiplication, we have negative 14x plus 5x. This results in negative 9x. Since we wanted positive 3x, we know that this factor pair is entirely wrong. We cross off this option, and we'll try the next pair. Now we have 2x times negative 5 plus x times 7. This is negative 10x plus 7x, which gives us negative 3x. We wanted positive 3x. We have the correct number, but the wrong sign, which is an easy fix. We will switch the plus and the minus inside the parentheses. When we factor 2x squared plus 3x minus 35, we have 2x minus 7 times x plus 5. Let's look at another example. What if we want to factor 15x squared plus 2x minus 8? We have a minus at the end, so we set up our parentheses with a plus and a minus. We need to factor the 15x squared, which would be 5x multiplied by 3x. Next, we have to factor the 8. This is either 4 times 2 or 8 times 1. As before, we make sure to write all possible pairings of factors. Now we can try to match the positive 2x from the middle term. First, we multiply 5x by negative 4 plus 3x times 2. This gives us negative 20x plus 6x, which is negative 14x. This is not correct at all, so we can eliminate this option. Now we try the next pairing. We have 5x times negative 2 plus 3x times 4. This results in negative 10x plus 12x, which is positive 2x. We found the exact thing we wanted. We are all set. So 15x squared plus 2x minus 8 factors to 5x plus 4 times 3x minus 2. The process for factoring when a is not 1 is very similar to that for when a is 1. We are still trying to unfoil the polynomial. We use a modified guess and check method to find the correct factors. Set up the parentheses, remembering that a minus at the end of the polynomial automatically means the signs in our parentheses will be plus and minus. Split apart the x squared term, then factor the constant term. When finding the factor pairs, we need to ensure that we write all possibilities. We multiply and combine the outside and inside terms to compare against the b from our problem. Either the number matches exactly and we are done, or the sign is wrong and we need to switch the signs in our parentheses, or the number is completely wrong and we have to try a different pair of factors. When writing the final answer, we have to be extremely careful with signs and orders of numbers. Little mistakes get magnified quickly. It never hurts to multiply out our final answer to compare against the original problem. This way, we can hopefully eliminate any silly mistakes.